Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोस गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोस गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोस रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें रिजॉल्विंग पावर एंड डिस्पर्सिव पावर ऑफ ए ग्रेटिंग विषय रे पढिबा ओके सो रिजॉल्विंग पावर गोटे प्लेन डिफ्रैक्शन ग्रेटिंग रो कहले हमें बुझिबा इट इज द एबिलिटी of the diffraction grating in order to produce the distinct images of two spectral lines which are having nearly same wavelengths, and it will produce the distinct images just as separated. Okay, so this is called the resolving power of the diffraction grating, and it is the measure of the ratio of the wavelengths of any spectral line and the difference of the wavelength between the two spectral lines at which they are said to be just resolved. Okay, so जदि आमे एठी wavelength नहीं जिबा lambda आउ lambda plus d lambda of the two spectral lines such that d lambda ही गला the minimum difference of wavelengths between them such that they are just resolved. Okay, ये जो just resolved already एटा आमे रेले क्राइटेरियन ऑफ रिजोल्यूशन रे पढ़ीछु प्रीवियस क्लास रे ओके सो जते बेले ए दुईटा जाको स्पेक्ट्रल लाइंस को हमें जस्ट रिजॉल्व कर देला बाय मींस ऑफ द डिफ्रैक्शन ग्रेटिंग देन रिजॉल्विंग पावर ऑफ दैट ग्रेटिंग इज गिवन बाय द रिलेशन दैट इज लैम्बडा डिवाइडेड बाय डी लैम्बडा ओके सो एज पर रेले क्राइटेरियन द स्पेक्ट्रल लाइंस आर said to be just resolved if the principal maximum of one falls on the first secondary minimum of the other. Okay, एटा हमें देखी थिला सो देखो आमे एठी कोन करिबा let us consider a parallel beam of light. Here you can see in this figure. Okay, these are parallel beam of light. Okay, and it is having two wavelengths, गोटे हला lambda आ गोटे हला lambda plus d lambda. Okay, let this beam be incident normally on a grating. Okay, this is the grating, right? And it is incident normally as we see, and let us say that the nth principal maximum of wavelength lambda, here it is shown by the solid line, this one. Okay, this is the nth principal maximum having wavelength lambda. Okay, it is formed in the direction having angle theta n. Okay, suppose point होची एठी p1 on the screen, right? ताले याको हमें in terms of equation लिखि परिबा a plus b sin theta n equal to n lambda. एठी a plus b हे गला कोन, this is the grating element. Okay, so गोटे हला width of opaque portion आ गोटे हला width of the transparent portion. Okay, अच्छा n होची एठी order which is 1 2 3 and so on. Okay, and the maximum is formed at the point p1 on the screen. Now the nth principal maximum of wavelength lambda plus d lambda. Okay, first हमें देखिला wavelength lambda रो, एबे देखिबा lambda plus d lambda which is actually formed in the direction now shown by this dotted line. Okay, and direction हे गला angle of diffraction, this angle theta n plus d theta n. Okay, then edit करछि, it will fall on the first secondary minimum of wavelength that is lambda. Okay, याको again हमें in terms of equation से बड़े लिखि परिबा a plus b sin theta n plus d theta n equal to n into lambda plus d lambda, and this is shown by the point p2 on the screen. Okay, as you can see here, this is our point p2. Okay, so the pattern ए भलिया पैटर्न हमें रेले क्राइटेरियन ऑफ रिजोल्यूशन रे देखिथिला. ओके, जो थरे कि principal maximum of one falls on the first secondary minimum of the other. Okay, so now if we say that there are capital N number of lines on the diffraction grating, then obviously we'll have n minus 1 minima in between two consecutive primary maxima. Okay, eta ame previous class re padichu. Okay, now the two lines will appear to be just resolved, mane just distinguished as separate if the diffraction angle, that is theta n plus d theta n, okay, eta d theta n habo, also correspond to the direction of the first secondary minimum, that is at the point P2 after your nth principal maximum, which is corresponding to the wavelength lambda at P1. Okay, so eta ketebale possible habo if it has an extra path difference which is lambda by n. Okay, so this lambda by n extra path difference must be introduced. Okay, hence for the first secondary minimum of nth principal maximum of wavelength lambda, we have a plus b sin theta n plus d theta n. Okay, এটা মনে রাখো, এটা ফার্স্ট সেকেন্ডারি মিনিমাম পাই, তেণু করি lambda by n additional path difference এটি introduce করা গলা, n lambda plus lambda by capital N. Okay, বহিরে টিকে এটি printing mistake থিলা. Okay, this should be capital N, right? Now using the Rayleigh criterion, the spectral lines of wavelength lambda and lambda plus d lambda will be said to be just resolved ketebale if the angle of diffraction of nth maximum having wavelength lambda plus d lambda is also, that is theta n plus d theta n, jota ki direction ta. Okay, so we can now equate the equation 6.62 and 6.63. as you can see here, duita jako equation. Okay, this one is the equation 6.62, this one 6.63. एठी LHS दुई साइड रे समान अछि, so एबे हमें RHS को easily equate करि परिबा. Okay, and after equating we just need to solve it. Okay, so after solving by resolving, we have the resolving power जोटा कि lambda by d lambda, यार value टा आसिला केते equal to small n into capital N. So that means the resolving power of the grating, number one, increases with increase of capital N, माने the number of your transparencies and opacities, माने जो number of lines अच्छी grating रे. Okay, ताकू जदि आमे बढ़ेबा ताले resolving power बढ़िबो. Then second point, it increases with the increase of the order small n of the diffraction pattern. Okay, ता छड़ा एठी resolving power independent रहिबो upon the grating element, that is a plus b. Okay, because देखो एठी RHS रे किछि भी a plus b रो फैक्टर नहीं, तेणु grating element उपरे एटा डिपेंड करिबो नहीं. Okay, thus resolving power of a grating, okay, एटा आ गुटे बहिरु मु नेछि, it is equal to the product of the total number of lines in the grating and the order of the spectrum. Okay, now आमे जन ऊपरे इक्वेशन देखिला सिथरो आमे जो यार ऑर्डर स्मॉल n को लेखि परिबा a plus b sin theta by lambda. Okay, एटा जदियो आ गुटे बहिरु नेछि, एटी थीटा लेखुछि थीटा n जगह रे, राइट? सपोज एबे कहिला आमे कैपिटल W to be the total width of the ruled surface of the grating, then आमे लेखि परिबा कैपिटल N equal to W by a plus b, that is total width divided by the grating element will give you the total number of lines, that is capital N. That means the resolving power जोटा आमे पाइथिला small n into capital N, यार एबे दुइटा जाको वैल्यू जो आमे पाउछु ताको रिप्लेस कर देले, we are getting W by lambda into sin theta. Okay, and for maximum resolving power sin theta must be equal to 1. Hence the maximum resolving power will be how much? That is W by lambda. Okay, so एतिकी जाए resolving power grating रो आमे जो देखिला, this is one method. Okay, besides that we have also an alternative method for calculating the resolving power of a plane diffraction grating. Okay, so again we consider the nth order principal maximum for the plane diffraction grating In case of normal incidence, it is given by a plus b sin theta equal to n lambda. Okay, this is the same equation, only difference is that it is theta n jagare theta boli lekhuchi. Okay, this I have taken from another book. Okay, so it is very much same. Now if we say that the wavelength changes by a very small amount, that is d lambda, then obviously the corresponding angle of diffraction also changes by a very small amount. Let us say that d theta. ताले ये जो इक्वेशन देखुच या आम डिफरेनसीएट कले एबे ये जो स्मॉल चेंज इन वेवलेंथ है डी लैम्बडा तापाई आम कंडीशन पाई परिबा एज यू कैन सी a plus b cos theta d theta equal to n d lambda, from which we are getting d theta equal to n d lambda divided by a plus b cos theta. Okay, so you can see here in the figure the light which is coming from this side, okay, parallel beam of light, and this is the grating. Okay, so after diffraction at the grating, it is entering inside the objective of the telescope, okay, in the grating spectrometer. Suppose small d is the diameter. Okay, यार diameter a objective रो हेगला small d, okay, telescope objective रो, and the smallest angle d theta dash or d theta prime, that is able to resolve for a light of wavelength, that is lambda. Okay, so this is the smallest angle d theta dash which can be able to resolve for a light of wavelength lambda. ताले d theta dash को आमे लिखी परिबा equal to lambda by d. Okay, ताले the two principal maxima in a certain order of the grating spectrum corresponding to the wavelength गोटे है lambda और गोटे है lambda plus d lambda, and having an angular separation d theta will be just resolved by the telescope. केतेबेले एटा संभव हो जेतेबेले एई जो d theta आउ एई जो d theta dash एई दुइटा जाको समान हे जिवो. ओके, ताले corresponding values को अबे हमें put करिबा. ओके, so देखो after putting the corresponding values and solving, एठी lambda by d lambda, this is nothing but the resolving power. So यार value आसीगला nd by a plus b cos theta. Now if the total width of the grating is suppose AB and it is containing capital N number of lines, then AB equal to n into a plus b. Okay, so total width जोटा कि आमे ऊपर देखुला W बोली कि लेखुला. Okay, same जिनस. So एठी आमे जदि लेखिला AC equal to D. AC माने कोन, as you can see here in the figure. Okay, this is AB, which is the total width of the grating, and AC is nothing but the diameter of the objective of the telescope. So AC को आमे लिखि परिबा equal to D, which is nothing but AB cos theta. Okay, from the figure which we are getting, so it is equal to n into a plus b cos theta. Okay, एबे यार value आमे replace करिबा substituting the value of small d, okay, in equation 4. Okay, ये जो small d रो value टा आमे पाइला ताकू substitute करिबा, then एठी तळे ऊपरे a plus b cos theta कटि गला. We are getting simply small n into capital N. Same result आमे पाइला by using alternative method. So it is clear from this relation that in order to use full resolving power of the grating in a certain order of the spectrum, the aperture of the telescope objective should be at least equal to AB cos theta, where theta is the angle of diffraction which is corresponding to that particular order of the spectrum, right? So ये हला resolving power. एबे देखिबा dispersive power कहले कोन. Okay, although it is not in your course, but this is for your knowledge purpose. Okay, so dispersive power of a grating is defined as the change in the angle of diffraction corresponding to a unit change in the wavelength of light which is used. Okay, so for nth order primary maxima or principal maxima, we have a plus b sin theta equal to n lambda. Okay, this condition we know. Now if the incident light containing more than one wavelength, okay, and different wavelengths bend differently when observed in the same order, माने यदि आम n को कांस्टेंट धरी नबा ताले डिफरेंट वेवलेंथ पाई डिफरेंट एंगल ऑफ डिफ्रैक्शन आसीबो. Okay, so greater angular separation between the two wavelengths, greater will be the dispersive power of the grating. Okay, so if two wavelengths, suppose again आम नेला lambda आ गोटे नेला lambda plus d lambda, which are producing the principal maxima of same order at two different diffraction angle, that is theta and theta plus d theta, ताले dispersive power of a grating is equal to d theta by d lambda. Okay, so ये जो ऊपर आम इक्वेशन टा पाई या अगेन वी डिफरेंशिएट विथ रेस्पेक्ट टू द वेवलेंथ lambda. Okay, and after differentiation and solving we are getting d theta by d lambda equal to n by a plus b cos theta. Okay, thus the dispersive power of a grating depends upon the following two factors. Number one, it is greater in case of higher orders, that is small n, and number two, it is greater for the gratings having smaller grating element, माने a plus b रो वैल्यू जिते कम हेबो सेति की dispersive power रो वैल्यू बढ़िबो. Thus the dispersive power, third point भी कहि पारो याको, is independent upon the total number of lines, माने capital N ऊपर एटा डिपेंड करिवो नाही, which are ruled on the grating, and it depends only on the number of lines per unit length. Okay, so number of lines per unit length ऊपर एटा डिपेंड करिवो rather than the total number of lines. Now at the end let us see how the dispersive and resolving powers of a grating are actually depending upon each other. Okay, so देखो angular dispersive power गोटे grating रो आमे पाइला d theta by d lambda equal to n by a plus b cos theta. Okay, so it is nothing but equal to n capital N dash by cos theta. Okay, so it is capital N dash माने कौन, it is the number of lines per centimeter of the grating surface. Okay, so from equation 1 जोटा एठी हमें देखुछु, it is clear that for a given order spectrum the angular dispersive power depends upon the number of lines per centimeter जोटा हमें ऊपर भी देखुथिला. Okay, so if the number of lines per centimeter माने n dash is increased, then the dispersive power will also increases. Okay, now resolving power जोटा हमें पाई थिला तारो वैल्यू केते थिला lambda by d lambda equal to small n into capital N. Okay, capital N कौन थिला एठी total number of lines on the effective width of the grating. मन रखो एठी कैपिटल N डैश होची नंबर ऑफ लाइन्स पर सेंटीमीटर, किंतु कैपिटल N होची ओनली टोटल नंबर ऑफ लाइन्स. ओके, सो सब्स्टिट्यूटिंग द वैल्यू ऑफ स्मॉल n which is a plus b sin theta by lambda. Okay, we are getting lambda by d lambda equal to w sin theta by lambda. Okay, so आमे एठी देखिया को पाउछु w कोन, दिस इज द width of the ruled surface of the grating. Thus the change in number of lines on the ruled width of the grating will not increase the resolving power. Okay, so number of lines केतेटा आमे ruled width रे नेइछु ताकू जदि चेंज करिवा this will not affect the resolving power. Hence at the end we can say that a grating with higher dispersive power, that means increase in the number of lines per centimeter, does not necessarily mean that it will have a higher resolving power, as the increase in number of lines per centimeter will decrease the grating element a plus b, but however the value of w जोटा थिला कोन ना width of the ruled surface of the grating, this will remain constant. Okay, hence this does not increases the resolving power. Okay, so we can say that the grating with greater number of lines will be superior. Okay, superior kaiki, because of the following 2 points. Number 1, with the increase in the number of lines per centimeter the dispersive power of the grating increases, and number 2, with the increase in total number of lines in the effective part the grating resolving power increases. Okay, so this is all about the resolving power and dispersive power of a grating.
Thank you.